Welcome to ClickMyProject.com. Diabetes is one of the most significant cause of mortality in the world today, and so we have to prevent the patients from getting diabetes. So, if a patient affected with diabetes, there are high chances of them getting affected with the heart disease also. So, to prevent a person from getting any cardiovascular disease, it is very necessary for a person to be diabetic free. And so, our project is about predicting the diabetes in a patient. So here we have used a machine learning algorithms so to be finding out the predictions, and the prediction results are accurate and precise and are easy to analyze. So machine learning is an algorithm in data mining, where a machine is loaded with some algorithms for the machine to implement some functions. We have also used the machine learning techniques here in different areas using IoT, that is Internet of Things. So here we are predicting the diabetes using ML techniques. This system is developed based on classification algorithms that includes decision tree, random forest, naive Bayes, and also logistic regression that is used as a for grid search CV. This is the flow of our project. Firstly, we'll be getting the data set, that is the diabetic patients data set from the UCI or from the Kaggle repository, and we'll be loading the input data. And after loading the input data, the data is being pre-processed. In this pre-processing step, any missing data are being handled, that is, it is either replaced or removed. And then the label encoding is performed if necessary, and after pre-processing is completed, the data set is now pre-processed, and then it is split into train and test set. In this step, the data are split into two sets, that is the train and the test set, and 70% of the data are splitted into the train test, and the remaining 30% are split into the test set. And even after splitting the train and the test set, the data are then moved on into the classification algorithm. Here several algorithms are being implemented on the data set to find out the predicted result. Firstly, we'll be implementing a logistic regression algorithm. The logistic regression algorithm is used as a hyperparameter tuning over here, and it produces some score. And after that, we have used a decision tree algorithm. Decision tree algorithm is implemented, and an accuracy and the performance is being predicted. And then we have used a random forest algorithm. Random forest is similar to decision tree algorithm here, but in case of random forest, voting is done. And then this data set is passed on to the Neighbour algorithm, where the model is created and the values are fitted and the values are predicted. And after the classification algorithm part is implemented, the data is then performed into performance analysis step, where the accuracy, precision, recall, and similar performance metrics are being evaluated, and the results are visualized. And now we'll be looking on to the running procedure of our program. I'll be running and so here is our results. So firstly, I've printed the data and I've read the data set, that is the diabetes patient data set, and I've checked for the missing values. Here there are no missing values here, so I've just printed the missing values. And this is the shape of our data set, and this data is after performing an upsampling. Like, upsampling is a function where we balance the data set. Like, if the data set is not balanced, we will not be getting an accurate result. So to avoid that, we have performed an upsampling method. So with this method, the number of data sets with diabetes and without diabetes are being balanced, and so we will get an accurate result. And so this is the data set. This is our entire data set, and this here the outcome, this will be our target data. This is our upsampling data set, that is after performing an upsampling function. And then we have performed an logistic regression, that is a twin logistic regression with some parameter and value, and the best score is about 77%. And then I performed the decision tree algorithm. The accuracy of the model is about 69%, and I've also displayed the precision recall F1 score in the support through the classification report. And then is the Gaussian naive-Bayes algorithm, and the accuracy of the Gaussian naive-Bayes algorithm is about 73.54%. And I've also printed the precision recall and F1 score of this algorithm. And finally, I've performed a random forest algorithm, and the accuracy of the random forest algorithm is about 73.54. And even for this, I've printed the precision recall F1 score and the support values. So here, these are our variable explorer. So I also plotted different data here. This plot is actually the heat map produced for the values with the correlation function, and this is the box plot for each of the data's columns that are available in the data set. Here it is the glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and the age. These are the columns that are available in the data set, and this is a pie graph that is done after upsampling method. So here we can be able to clearly see that the number of zeros and ones labeled columns are being nearly to equal. So due to this, we can produce a better result accuracy. And this is the comparison graph for the three algorithms that we have performed: the decision tree, the random forest, and the naive-Bayes. The decision tree algorithm, the accuracy was about 69% over here, and then for the accuracy of the naive-Bayes was about 73.5, and for the naive-Bayes, for the random forest, it is about 73. So here the random forest produces a better prediction result compared to the other algorithm, that is the decision tree and the naive-Bayes algorithm.